In this lesson, we're going to learn how to balance an unbalanced chemical equation. So let's take a look back at this example that we started earlier. H2O yields H2 plus O2. We determined that this is a not balanced equation because the oxygens on the reactants and the product side are not the same, so this is not balanced. Now, when we're balancing, you can only use coefficients. You cannot add, remove, or change the subscripts. All right, so knowing that, there's an order of things to balance. You have to look at your polyatomics first, then hydrogen, then oxygen, and then everything else. All right, so let's go through the list. This has no polyatomics, so it's good. Hydrogens, 2 in the reactants, 2 in the products. Currently, that's balanced. Oxygens, 1 on the reactants, 2 on the products. All right, so that's unbalanced. So I'm going to try to get the reactant side to 2. To do that, I'm going to put a coefficient of 2 in front of H2O. Now this coefficient gets distributed or multiplied through the entire compound. So it gets multiplied to the hydrogen and to the oxygen. Our hydrogen becomes 4 hydrogen atoms. 2 times 2 is 4. Our oxygen becomes 2. So now our oxygens are good. We have 2 oxygens on the reactants, 2 oxygens on the products. But in balancing it, our hydrogens are now unbalanced. 4 on the reactants, 2 on the products. So to help balance this, on the product side, I'm going to use a coefficient of 2. It gets distributed to only the hydrogen. The plus sign splits them up. So it gets distributed to only the hydrogen. 2 times 2 is 4. We now have a balanced chemical equation. Let's take a look at this example. We also determined that this one was unbalanced. A little bit more complicated, so let's walk through it quick. First thing we're going to look at is polyatomic ions. And we realize that we have sulfate and hydroxide as polyatomic ions. So we need to make sure they're both balanced. So if we look at our sulfates, we have SO4. We have 3 of them in the reactants. We have 1 in the products. So to help balance this, I'm going to put a 3 on the product side. That 3 gets distributed to both the calcium and the sulfate. So we end up with 3 sulfates and 3 calciums. Now, our hydroxide is a little different. We have 2 hydroxides in the reactants, 3 hydroxide in the products. What I'm going to do is I'm going to find the least common multiple, or the number that both of them will multiply into, the smallest number. And the smallest number both of them multiply into is 6. So I'm going to try to get both of these to 6. On the reactant side, I need to use a 3. That 3 gets distributed to both the calcium and hydroxide. So our calcium becomes 3, our hydroxide becomes 6. Okay, now on the product side, I'm going to use a 2 to get this to a 6. So put 2 in front of the aluminum, gets distributed to both. We get Al2, and then 2 times 3 for the hydroxides. We get 6 hydroxides. Polyatomic ions are now balanced. Hydrogens are balanced. Oxygens are balanced. Anything that's left is balanced. So the entire reaction is now considered to be balanced. So when balancing, you can only use coefficients. A coefficient will multiply through the entire compound, and there's a specific order you have to follow. Polyatomics, then hydrogen, then oxygen, and then everything else that's left.